Welcome to this video from the P-Way Engineer. In this video, we'll explore the various ways that railway crossings can be constructed. From the cheapest options to the type commonly used in high-speed lines, you'll learn about the different construction types available. We'll also delve into the material processes that make crossings more resistant to wear and damage. So sit back, relax, and join us as we guide you through the world of railway crossing construction. And as always, we welcome your thoughts, experiences, and questions in the comments section below. So don't hesitate to share your knowledge or ask any questions that you may have. We're eager to hear from you. Crossings play a crucial role in railway junctions, and can be built using several methods. First up is the fabricated crossing. Sometimes these are also called built or made-up crossings. This is the cheapest style of crossing to manufacture. The crossing is constructed from 4 pieces of rail that are suitably bent and machined, then drilled and bolted together with high-tensile steel bolts. Multi-groove locking pins, or MGL pins, can also be used. Spacing blocks are used to create the flangeways in the crossing. The crossing nose is formed by 2 of the pieces of rail, one known as the point rail, the other as the splice rail. The point rail forms the actual top of the crossing nose. The splice rail joins the point rail back a little from the nose. You can see the join on the crossing. Damage to the crossing in this area can be hard to weld repair because of the joint between the 2 rails. Whilst built-up crossings are cheaper and quicker to make, they are also significantly weaker due to the number of parts, the holes drilled to connect them, and the fastenings used. This can lead to faster deterioration compared to other crossing types, as well as limits on where they can be used. In the UK, the use of built-up crossings is limited to track that has a lower speed and tonnage, as well as sidings. Another limitation for built-up crossings is that, due to the way they are constructed, they are not strong enough to be stressed, therefore are normally jointed into track. The presence of joints can lead to track geometry faults, such as dip angles and voiding. Next up is the part fabricated crossing. Although there are 2 different subtypes of part fabricated crossing, they both follow the same general principle. In a part fabricated crossing, the V is 1 piece, rather than 2 as in a built-up crossing. This is achieved by either electro-slag welding the point and splice rails together in the manufacturing plant, or by the use of a cast V. This is known as a cast center block crossing. To this V, wing rails are then bolted, in a similar fashion to in a built-up crossing. Part fabricated crossings are stronger than a standard built-up crossing, which allows them to be used in CWR track, as well as higher usage and tonnage lines. Lastly, we have the cast crossing, also known as a monoblock crossing. In this type of construction, the crossing is cast as a single item, hence the term monoblock. Monoblock crossings are cast from a steel alloy, austenitic manganese steel, or AMS for short. AMS has good anti-wear properties, high tensile and impact strength compared to the normal grade steel used for standard rails. These properties increase over time, as the metal is what's known as work hardened. Work hardening is when a metal is strengthened by hammering, rolling, or another form of mechanical process. In the case of a railway crossing, work hardening is done by the wheels of trains passing over it. This does take time, and can lead to uneven hardening. To give a level of work hardening prior to installation in track, the crossing can be explosive depth hardened. This process involves laying a blanket of plastic explosive across the running surfaces of the crossing, then detonating it. This causes localized deformation that work hardens the metal, creating hardened material that is better equipped to withstand the passage of train wheels. As the monoblock crossing is a single piece, It removes one of the major drawbacks of the fully and part fabricated type crossing, the weakness created by the bolting together of the components. This means that AMS monoblock crossings are the crossing used in the higher speed and tonnage lines. They do, however, have some drawbacks and limitations. Firstly, AMS cannot be directly welded to the normal grade steel. To solve this, a small stainless steel insert is welded between the AMS and normal grade steels. This is completed at the manufacturer rather than on site. Defects in this area are tricky to weld repair, given the 3 different metal types within a small area, and often the weld repairs fail. Monoblock crossings are also expensive, given the manufacturing processes involved as well as having long lead times. This means that any issues with them, such as cracks or defects, that cannot be weld repaired can be awkward for the maintainers. This often leads to spare crossings being ordered and stored for critical junctions. This brings us to the end of this video. You can now name the different types of crossing construction, as well as some of the pros and cons of each. We hope you have found this video informative and have learnt a lot. If you want to see more like it, be sure to hit the subscribe button and join our community. We have a lot more exciting content on the way, and you won't want to miss a single video. And while you're here, why not take a moment to explore our channel and see what other fascinating topics we cover? There's so much to learn, and we're always adding new videos to keep you informed.